All right, good morning, everyone. So it's 10 a.m. We'll get started. Thank you for joining us this morning for our Introduction to IAB webinar. This is going to be presented by our Amanda Fletcher here at Gerrie Electric. For anyone that doesn't know me, my name is Amy Carter, and I'll be acting as your moderator for this event. So just a quick overview of this format. We're using Microsoft Teams Live as this platform. This allows us for question and answers as well to be submitted from your chat window. So feel free to ask any questions as we go along, and as the webinar progresses, I'll sit here and try to answer them live as they pop up. So now I'm going to turn things over to Amanda and we'll get started.
Good morning, everyone. So like Amy said, I'm Amanda Fletcher. I am the Automation and Software Product Specialist here at Gerrie Electric. So we're just going to be doing an introduction to IAB. So IAB is just a system that you can use to design your PLC system, and it'll tell you if you're having any problems with it. As you can see just in this PowerPoint on the side, it'll tell you if your project's okay, and your field power status, and your control power status. So why use IAB? It just ensures that all required parts are included in your bill of materials. So it'll catch those little things that you might forget, like power supplies and terminal blocks. And it makes sure that your power supply is properly sized. You don't want to undersize or oversize that. And it makes sure that your devices are compatible and that your controllers aren't overloaded. So in this webinar, we're going to cover the different methods to add a system. So the two that we're going to cover are configuring a system using the wizard and how to configure the system manually. We're also going to do an SLC migration because those are really popular right now. We'll just go through the different features of IAB and creating bill of materials and reports that you can send to your customers. So we'll jump right in it and start with the live demo. Okay, so when we first open up IAB and we create our project, this is the screen that we'll be taken to. I'm just going to collapse that a bit, make that one a bit bigger. Okay, so we see that we have, right now we're in the wizard view, and we have a couple different icons here that we can click on to start our system. So we have the project design assistant, we have control logics, compact logics, micro 800, distributed I/O, Clamp PX, 1771 migration, Slick migration, and distributed I/O migration, as well as the micrologics migration and Ethernet IP capacity. That'll tell you how much of your network's being used. So we're going to start off by doing a control logics system. So we'll click on this control logics icon, and that opens us up to this wizard page. So on this wizard page, we can choose our chassis preferences. So if we're using our chassis in somewhere like there's going to be extreme temperatures, if it's a redundant controller chassis, if it's going to be using redundant I/O adapters to allow I/O in the controller chassis, and to add slot fillers to empty slots. Also, we can choose how many spare chassis slots we would want, and if we want to add historian modules. So for chassis sizing, there's 4, 7, 10, 13, and 17 slot sizes, but you can also click auto size and the system will pick the right chassis for you. For your chassis power supply, you can select if it's redundant, your voltage, if it's 120 to 20 volts AC, if it's 24, 48, or 125 volts DC. You can choose your I/O wiring method. So there's screw, there's clamp, I/O ready cable, and wiring systems with pre-wired cable. And then you have a section here to choose spare I/O points. I always like to add some spare I/O because you never know if your project scope is going to change a little bit or if stuff gets added on later down the road, and you want to make sure that you do have some I/O that you can connect to. And then down here is the control logics network preferences. So this is how you would communicate to a distributed I/O rack if you require 2 racks. So you can choose to create new network and only if necessary to support required I/O. And you can have it as control net or Ethernet. And then you can choose your topology, if it's star, linear, or ring. And it'll also select a switch for you. So we're going to leave this at allow IO and controller chassis, auto size, and 120/220. I'm going to add 5% spare IO, and I'm going to leave this as only if necessary to support required IO. We won't actually end up having a network here because we're not going to have enough IO that we're going to fill up a whole 17 slot chassis. So we can go ahead and we can click next. So here's where we can select our digital inputs. So we have a choice between AC or DC, isolated and non-isolated. For AC with voltages of 120 or 240, we can choose diagnostic modules for the non-isolated. For DC, we have sync isolated, sync non-isolated, and source. And we can choose 12, 24, 48, or 120. And again, diagnostic on the sync non-isolated. So we'll add in for 12 isolated AC, and we'll do 12 isolated sync for the DC. And we'll just keep them at the 120 and the 240. And as you can see down here, it is taking into account the spare IO points is currently set to 5%. So when we finish our system, we'll see the number will be a little different than 12 because it has taken into account that 5%. So we'll click next. So now we're at the digital outputs. So there's AC output, DC outputs, and contact outputs with the same voltages available. There's diagnostic, but there's also now fused available. So we'll click 12 isolated AC outputs, and we'll do 12 DC outputs. Again, down here, it's saying that our spare IO is set to 5%. So we'll click next. So now we get to choose our analog IO, and we've got a couple different options for inputs. We've got single-ended, differential, high-speed, voltage isolated, current isolated, RTD, thermocouple, and HART. And for the outputs, we have voltage isolated, voltage non-isolated, current isolated, current non-isolated, and HART. We'll just choose, let's do 6 single-ended, and we'll do 2 RTDs. And for the outputs, let's do 4 voltage non-isolated. Again, down here, it says our spare IO points is currently set to 5%. So we'll go ahead and we'll click next. So here's where we can enter the number of axes if we're using motion. In this demo, we're not going to be using any motion, so we're going to keep it at 0. But you also have the option to choose the communication protocol for your motion, if it's SIP motion or if it's Circos. Again, it's automatically defaulted to Circos. It's not going to take effect because we do not have any axes of motion. So we'll click next. And then here is where you'll do your distributed IO and additional network module. So right now, by default, it's all at no additional network. We can choose to create a new network and then control net or device net. And if we want to use redundant media, we're going to keep that at no additional network, and we're going to click next. So right now, it's given our system a name. We can change that if we want to. So let's change that to control logics. And then it's selected our processor. It tells us the quantity. It's selected an Ethernet bridge module. And then these are the modules that it has selected. And because we chose 5% spare IO, instead of it saying 12, it's saying 13 because it's taken into account that 5%. And then if we're not happy with these modules, we maybe want conformally coded, we can change that and select it just like that. I'm going to put that back just to the isolated regular one. And then down below, if you want to add specialty modules, you can do so by clicking the up arrow, down arrow to take it out. So that is our system, and it's complete, so we can click finish. So it automatically takes us back to this wizard screen. But if we want to view that system, down in the left here, we have some tabs, the IAB bookshelf, the architecture view, the hardware view, your network view, your on-machine view, and your wizard. Right now, we're in the wizard view. So we're going to click on the hardware. And here's our rack. I'm just going to minimize that so we don't have to scroll over. Here's our rack. So it shows as it's a 10 slot rack. All our modules that got selected and added in. If we want to see this in a bit more detail, we can drop this out, click on this plus one more time, and it tells us the module that is in each one. And then it tells us that slot 8 and 9 are empty. So if you want to put in slot fillers, you can right click on here, click configure chassis, or you can just double click on here. We can change it to 13 slot if we want and click OK, and it will do that. I'm going to put that back to a 10. We can change our power supply if we want. We can also change our terminals. So right now it's selected all screw terminals, so we can change that to clamp or the IO ready cable from here. So we'll just leave that at screw and we'll click OK. And then we can also choose to add slot fillers to the empty slots. So we'll check that and we'll click OK. So now we have the 1756-N2 in those slots, which are the slot fillers. We can click on here and it will tell us what we're using. So the processor that's in there is a little description about it, as well as the dimensions and a picture. And it will do that for each module. You can also click on here and it kind of opens it up so you can get a real life look at what the module looks like. And then just over here, sorry, I'll expand that out. It tells us that it's not, control power is not required. It tells us the power supply we're using, the amount that's being used, and the amount remaining. This is important to know because you want to make sure that you're not selecting a power supply that's too small or oversizing. It says it's not satisfied by the field power, and it also says that there's warnings detected. So if we go up here to the project completeness wizard, we'll click on that. We have an exclamation mark because it's not an error, it's just a warning. So we'll click on project checker and we'll click on here and it says your project is using a 1756 IRT8I. If you use this module with thermocouples and an RTB, then you need the CJCs. So it's just giving us that little warning that there is an accessory that we need to purchase if we are using it with thermocouples. So we'll click OK. And there's some other stuff that we're going to go over when we create the new system manually. So right now, we're just going to minimize all this. That's our control logic system done for now. And we're going to add another system. And we're going to do a compact logics. So we're going to click on this icon here, which says new hardware. And it gives us all these options for control logics, compact logics, micro 800, micro logics. It's even still got SLIC and PLC5 in there. If you're just doing an IO chassis, safety, specialty IO, motion, HMIs, overload relays, and even Encompass partner products. So we're going to do a 5380 L3. So we'll click on that. Populates with a little picture and a product overview. We can change the name here if we want. So let's change that to Compact Logics. And we'll click OK. So by default, it just puts in a 4-slot chassis. I guess it's not really chassis for Compact Logics because they just click onto the side, but it just shows us the 4 slots. So if we know off the top of our head what controller or module we want to put in there, we can go to this search box here and type it in. So we'll type in 5069 L306ER and we'll click enter. Let that load and it comes up with all the ones that match. So we're just going to use the L306ER. We don't need motion or anything. So we'll drag and drop that in to the first slot. So here right now it's saying that empty slots are not included. So it throws a little error because it doesn't allow for empty slots. So we can change that here, but we'll be adding some modules. So along the bottom, it shows our search results, our favorites, the SLIC 500 system, PLC5, Encompass partners, other networks, power networks, Ethernet IP, device net, control net, other hardware, so like your computers, your drives, Safety, you have here motion, distributed I/O, micro 800, micro logics, and then user devices, control objects, and compact objects. So we're doing compact objects, so we're going to click on this tab, and these are all the controllers. If we didn't want to search for it, how we can find them. Then you have your I/O. So let's say we were to try and add a 1769 I/O. It's not going to allow us because it's not compatible with this chassis or controller. So we'll minimize that. We'll minimize the 1769 I/O, and we'll expand the 5069 compact I/O. So it gives us the option for power supplies and I/O modules. We'll expand I/O modules. We'll add analog first. So we'll add a 5069 IF8 from the inputs and a 5069 OF8 from the outputs. We'll just drag and drop those in. Add in some digital. We'll do an IB16. I also want to add an output, but I don't have room. So I'm going to right click on this controller and I'm going to click configure chassis. And I can click on these arrows to, pardon me, sorry, to make it smaller or larger. So we're going to make it larger. So we're going to put it back up to 5. And we can also here change if they're screw or spring terminals. We're going to leave them at screw. You can also change your default here. So by default, it's at screw, but you can change it to push in and click apply default, and it automatically changes all of those. So we'll change that back to screw and click apply default. You can see that that changed back to screw. So we'll click OK. And then it will show us the power being used and the power remaining. We'll click OK. So now we have another empty slot here where we can add a module. So we'll add in that OB16. So notice how that empty slots not included message went away because we've now filled up all of these slots. And same thing, we can click here, it'll tell us the catalog number, a description, and if there might be a little note or anything that we need to be aware of. And I'll do the dimensions and everything. So I'm going to go into detail more on the properties for this one. So it says it's not satisfied by the control power, shows us the power used and power remaining. It's not satisfied by the field power. Project status of this one is okay, and it tells us the height. So for this one, we're actually going to configure that control power and that field power. So we'll go up here. There's an icons along here that look like little power supplies, and the one for C is that has a C is for control power. So we'll go ahead and click that. And you can filter your product by the different groups, if it's the essential or the compact or performance power supplies you want to use, your input voltage, and your output current. We're going to use an essential one, but we're not going to filter by voltage or anything. And we'll just select this first one and we'll click add power supply. So right now it's showing 0% because we haven't attached anything to that power supply. So to attach that compact logic system, we're going to click on here and we're going to move it over. So now it only is using 20% of that power. So we'll click OK. Now it says it's satisfied by the control power wizard. It shows us the power supply we're using, and it shows us the power used. So for field power status, we'll configure that one too. We'll go to the power supply that has an F. We'll click on it. By default, it checks both the systems, and it'll say one power supply for entire chassis. Inputs and outputs use same power supply. Or you can choose one power supply for inputs and one power supply for outputs. And it's the product power supply that we're using is the one that we had selected. So the essential, the 100 to 120 volts AC, 5 amps, and we can click apply default. So it's going to apply all of that to our two systems. Then we can click here and do chassis specific. And it shows us the power supply it's using and how much it's using of that power supply. So this one is 80% loaded, this one's 100% loaded, and then this one's 80% loaded. You don't necessarily want that, so you can change it about to fit your application. We're just going to leave it how it is at this time, and we're going to click OK. So now it says that it is satisfied by the field power. And you can go back in here and click power supplies, and it shows you the ones that are being used and whereabouts they're located. Don't know if you guys can see this, those little arrows right here, 1, 2, and 3. Sorry, 3 right here. And you can go back to configure chassis if you want to make any changes. So now we'll go back to Wizard View and we'll do an SLC migration. So we'll slide over here. We'll click on SLC migration. You can name your chassis. So you click add chassis. We'll just leave it at the default name of SLC 001 and we'll click OK. So it shows us right now we're doing it where we retain the IO, but we're replacing the processor with a 1769. That's why you're seeing 2 SLC chassis and then a compact logics chassis here. But we're going to choose replace with 5069 compact logics. So it's going to just give us that SLC chassis, and then it's going to give us the compact logics rack here. So you can choose your chassis size if it was 7, 10, 13, or down to 4. You can change your power supply. Gives you all the different options. We'll keep it at the P1. And then down here on the left, it shows us all the SLCs. So we've got adapters, the COM interfaces, IO modules, motion, any other one. So it's just like a generic module, our processors, our scanners, and our specialty modules. I'm going to minimize those. And we're just going to choose the 1747 L514 and we'll drag and drop it. So now it pulls up all the processors which we can use. So we're going to choose the 5069 L306 ER because this one's only 4 kilobytes of memory and this one's 600. So there's no issues there. So we'll click OK. And it populates it in here, and then it populates it with the 5069 L306 ER controller down here. Minimize that. So if we want to add some IO, we can go to analog, and let's say we were using NI4, we'll drag and drop that in, and it will put the corresponding compact logics module in here. And we can do that for digital. Do an IA8. That gets added in, and we'll do an OA8. And just like that, it just keeps dropping in the compatible hardware. And if one isn't compatible, it'll give you a note and tell you an article that you can go to, or it'll just say it's not available, contact Rockwell, and they'll be able to help you come up with a solution. So this is our system. We'll click OK. So here's our chassis here, and then we can click on Generate Hardware. And we'll click on the Hardware tab, and here's our system. So if we click on that, it shows us everything here, and it says warnings detected. So we'll click on that project wizard again, and we'll go to Project Checker. And it's just because of that control logics again, as we can see, the slick migration is okay, and the standalone compact logics is okay as well. So for project add-ons, we can see that it's satisfied by the control power wizard. It's satisfied by the field power wizard. This one is to add components. We're not going to do that in this demo, so we're going to leave that one at a red X. And for software wizard, so right now we have no software. If we click on this, double click it, we'll say yes, we want to establish an internet connection. That way everything's up to date. We'll let that load. Takes a minute. Then opens up this software. So it's chosen the Studio 5000 Standard Edition. It says quantity 1, and it gives us the part number. And it just tells us that this software is required for programming the control logics and the compact logics. If we want to change maybe we want to do Pro Edition or Full Edition, we can click Browse Catalog. We can expand out Studio 5000, and we can choose whatever one we want just by putting a 1 in here or by clicking the plus here. You can change that to a 0. So we'll click Review Bill of Materials, has that one, and we'll click Finish, and it's automatically going to add it to our bill of materials. So now we have a green check mark here, so we're going to click OK. So up here, we have the option for a quick bill of materials, which just does that on the system that you're currently on. So it will do it for the slick migration. And we have the option to have a positional bill of materials. So it will tell us the position or the slot where it is, and it will include those terminal blocks, which are commonly forgotten. Or we can do consolidated. So it will combine all the terminal blocks if there's multiple ones, and it'll tell you quantity 3 and then ones for everything else. And you can export this to an Excel document. So if we click Save to XLS, we'll just keep the file name how it is, and we'll click Save. We'll click Yes to open the saved Excel file. And it opens up an Excel file, and it just gives you some little notes up here that your project has errors and or warnings, and that was the one about that added accessory. And it will give us our quantity, the part number, and any additional information. So we can close that and close that. So now there's also a project bill of materials. So if we click on that, we'll click yes, because we do know about the errors and warnings that are in there. So it'll always give you this pop-up whenever you go to generate any report or bill of materials. Say yes, because we're aware of it and we still want to generate the project bill of materials. We'll click yes to save the changes. And then this one comes up with one for each system, and it'll break it out by control logics, compact logics, as well as SLC migration, and then our software, our control power, and the field power supplies. So all this pricing that you're seeing here is list pricing. And again, we can do an organized bill of materials, so that's organizing it by the systems. We can do a consolidated bill of materials, or we can do a positional where it will break it down by the system, but it will have each slot listed. We can save that again, say yes, save, yes, open. There's our Excel document with all the pricing this time and anything that you could possibly need with the little notes. So we'll close that. Now, if you wanted a full report of everything that you have in here, you can click on this report here, which looks like the Word document, and it's to create a report. So we'll click on that. And it tells us that, a warning was detected. If we want to add any components or remote I/O, we'll click yes, we want to continue to generate the report. We'll save it. We'll click OK. It just tells you a little lawyer blurb about, it's just a design assistant and nothing is like, it's not a full configuration as such. So we'll click OK. It's an as is. Takes a minute to load up. And we'll click yes that we want to open it. And we'll click yes to any of the pop-ups. It's just sometimes the layout is a little off and Word has to rearrange things. So it tells us our name. It gives us a little picture here from IAB, and it even includes the date and the time. gives us a table of contents, and then it gives us an overview of everything that the system does. And then it gives you a description of the product family that you're using, so control logics, the project warnings and errors. It'll tell you where the project list, what project system had an error or warning. And it's just that little blurb about using the CJCs if we're using thermocouples with this module. Tells us our hardware platform list, gives us a little image of each system, a bill of materials for each one, and then a more in-depth view of each system. So all those properties that we were seeing on the right-hand side with the power being used, control power status, and the dimensions. And then it'll give us all the catalog numbers, the dimensions of those individual ones, and it'll do that for each system. We'll just skip over those two because they're just the same as the control logics. And then if we have any added communications, it'll show that in here. We don't, that's why it's so small right now. And if there's IO, any additional IO, HMIs, produce consume tags, motion, any logic, and then just our warnings and stuff for those IO devices, HMI devices, and networks and produce and consume tags. And then just the appendix and the SLC system here that we entered and what it converted it to. So we can close that. We won't save this one, but obviously save it if you want to save it. So if we wanted to duplicate one of these systems, what we can do is we can click on here, right click, and click duplicate device. So now it will say Compact Logix copy 1. If we wanted to rename that, we click on rename device. It's just like doing a Word document or something. We'll delete that and we'll just put a 2 there. And now we've changed our name. Now let's say we don't want this system anymore. We can click on here and we can click delete device. It'll ask you if you're sure and if you really want to delete it, and we're going to say yes. So now we've deleted our device and we're left with just this Compact Logix System 2. Then if you wanted to save this entire workspace, you can go here and you can click on Save Workspace and it will save it under this webinar demo name. Or you can click File again and click Save Workspace As, and you can change that name. And then if you wanted to open an existing workspace, you would just click on Open Workspace and it will pull up all the different ones. Got all these different tabs where you can export it to Proposal Works, export it as an XML, and you can even import into here, create a Word Writer report is another way to do it from here instead of doing it from over here. And I'm just going to show you this, which is if you want to complete your architecture by adding any input devices, output devices, so like your push buttons, your stack lights, wiring solutions, circuit protection, and power solutions. And then there's just these different views of architecture view over here. We can even add an area. So we can click on add area and we can just drag a box around it and then it names it as area 1. And if we wanted to rename that, we can click on it and we can just delete that and type in area. So if there's different areas of the plants and click enter, you can do so, and then you can click on world view and I'll show you where everything is. It's not much different from this view. You can add a text label by just clicking on this, and we'll just type in this is my system. Click enter, and it puts it up here for you right there. You can click on this configure. If you are adding any physical connections, you can change the color. So right now it's set to green, you can change it to blue, any colors that you're thinking of, and it will even tell you like Ethernet IP, control net, just the typical colors of those device and what their trunk color is going to be. And then you can just reset to IAB default. If you change anything, we'll click OK. We're going to click cancel because we don't want to save anything of what we just did. So that was it for the live demo. So if you have any questions, you can type them into the chat and we'll get back to you as soon as we can. Once again, my name is Amanda Fletcher. I'm the Automation and Software Product Specialist here at Gerrie Electric. Here's my email and my cell. If you have any questions or just want to see how something's done, feel free to send me an email or give me a call, and I would be more than happy to help. On the 25th, I believe, we also have another IAB webinar coming up on networks that Amy will be doing. Thank you guys for listening.